So here is another question on graphical analysis of one-dimensional motion. So it is given that a ball is thrown upwards with an initial velocity of 100 meters per second. After how much time will it return? And we have to draw the velocity time graph for the ball. And from the graph we have to find the maximum height achieved by the ball and the height of the ball after 15 seconds. Here we have to take acceleration due to gravity small g equals to 10 meters per second square. Okay, so again it's related to motion of an object under the influence of gravity, which we have discussed a lot of questions and equations of motion and also some in graphical analysis, but different variations. Okay, so it is given that a ball is thrown upwards, let's say from the ground here, okay, from the ground a ball is thrown upwards with a velocity of 100 meters per second, which is the initial velocity. So it will move upwards, and as gravity is acting downwards, it will be negative. It will oppose the motion. So finally the ball will come to rest with final velocity 0 meters per second. So here if we want to remember the time, so what we want to plot, the velocity time. So two parameters that are important are velocity and time. So the time for which it it goes upwards and comes to rest, that time we have to find using v is equal to u plus at, this equation of motion. Final velocity is 0, initial velocity is 100, a is equal to minus g because it is opposing motion, and then we have to determine the time. So it is 100 minus 10 t. So we'll take 5-second intervals. So velocity at the end of t equals to 5 seconds. Okay, for that from here this equation, velocity at the end of 5 seconds is 100 minus 10 into 5, which is equal to 50 meters per second. Velocity at the end of t equals to 10 seconds is 100 minus 10 into 10, which is equal to 0 meters per second. And at t equals to 0, it is initial velocity, which is 100 meters per second. Okay, these are the important points. This one, this one, this one for time 0, 5 and 10 seconds. So it take 10 seconds for the velocity to go upwards to rest, okay, to the final velocity 0, the rest position. Now if you have watched my video related to motion of an object under the influence of gravity and some questions that I have discussed previously, there we have discussed that when an object is moving under the influence of gravity, they have some important properties, like the time taken by the object to move upwards under the influence of gravity and finally coming to rest, it takes the same time to come downwards. Okay, it takes the same time to come downwards. So the final velocity here 0 meter per second during the upward motion, it becomes the new initial velocity, and now it moves with gravity, with the support of gravity, and it will come downwards with the same final velocity, that is 100 meters per second at identical point. This. Here the time taken upwards is 10 seconds. Here it will be 10 seconds downwards. So it will take a total of 10 seconds plus 10 seconds, which is equal to 20 seconds, to finally return to the ground. And during this downward motion, the equation will be V is equal to U plus AT. Gravity is acting downwards, it is in the direction of motion, supporting it, so it will be positive. During the upwards, it was against the motion because movement of the ball was upwards, gravity was downwards, that's why it was negative. So here it will be V is equal to U plus GT. So velocity at t equals to actually it will be t equals to for the downward phase it is t equals to 5 seconds, but in totality it is how much? 10 plus 5, 10 plus 5, which is equal to 15 seconds. Okay, for the downward motion it is 5 seconds, but in totality it is 15 seconds. So that is equal to how much? 0 plus 10 into 5 gt, which is equal to how much? 50 meters per second. And V at t equals to 10 seconds of downward motion, and totality 10 plus 10 equals to 20 seconds, that is equal to 0 plus 10 into 10, which is equal to 100 meters per second. And velocity at t equals to 0 seconds, or in totality 10 seconds, that is equal to 0 meters per second, which is this one. This is the upward motion from 0 to 10 seconds. Here it is 0 seconds, here 50 meters per second, somewhere halfway around at 5 seconds, and this at 10 seconds. Here during the downward motion, for this downward motion it is at 0 seconds, which is basically at 10 seconds. Okay, same thing here, somewhere around in the middle it is 5 seconds for the downward motion, but in overall sense it is 15 seconds, and here it is 10 seconds in the downward motion phase, and overall it is 20 seconds. Okay, again for this downward motion these are important things. Okay, this one, okay, this one 10 seconds, and here at t equals to 15 seconds it is 50 meters per second. So now here if we want to plot the velocity time graph, okay, if we want to plot the velocity time graph, okay, so this is the thing. Okay, so here it is, the values are for velocities is 0, 50, 100 velocity, and for time it is 5, 10, 15, 20. This is the time in seconds. Another important thing here is that during the upward motion, when the movement of the ball is upwards, velocity will be positive. This is during the upward motion. And during the downward motion, when the velocity or the movement of the ball is downwards, velocity will be taken negative, minus 50, minus 100. So at t equals to 0 seconds here, the velocity of the ball is 100 meters per second. It is thrown upwards, so positive, this point here. T equals to 0, 100 meter per second, that's the first point A. Then at T equals to how much? 5 seconds, it is 50 meters per second. T equals to 5 seconds, it is equal to 50 meters per second here, this point. Then at T equals to 10 seconds, it is again 0 meters per second when it comes to rest. Okay, when it comes to rest against gravity. Then at T equals to 15 seconds, this one, it is how much? Downwards, 50 seconds, downwards during the downward motion. This one here, 15 seconds, it is 50 meters per second. So it will be somewhere here, this one. And then at T equals to 10 seconds or 20 seconds, it is 100 meter per second. Again, during the downward motion, it is negative. So at 20 seconds, it is 100. This one. So the velocity and time plot will be somewhat like this. From here, joining these points. Okay, so it is not the graph is not like this. Okay, somewhere. Okay, so the axis which I have drawn, it is I have not drawn it perfectly, so it will come somewhere around here. Okay, this one will be like this here. Okay, so here I have not drawn it to scale perfectly, so that's why it is like this. So this will be the first point, A, B, C, D and E. Okay, so here I have not drawn it. See, this 0 to 5 and 5 to 10, they are not equal spaced. So that's why this is slightly, it is here. So it will be like this, like this. Okay, now here it has been asked that from the graph we have to find the maximum height achieved by the ball. So the maximum height or the maximum displacement is during the positive portion, okay, upwards of x-axis or the time axis, which is basically the area of triangle AOC, this one. Okay, AOC. So the maximum height reached, that is equal to 1/2 into base into height, which is OC into OA, that is equal to 1/2 into 10 into 100, 5, which is equal to 500 meters. Positive side, upwards, because positive velocity means it is movement of the ball upwards, up and up. This is the maximum height. Then it has been asked to find the position of the ball or height of the ball at this point, 15 seconds. So let's say this point is F. Okay, let's call it F. This point is F. So this will be the height of the ball at 15 seconds. It will be area of triangle AOC plus area of triangle CDF, because area under the velocity time graph gives us distance or displacement. Now as it is in the downward side of the time axis or x-axis during negative velocity, it will be subtracted. So let's see how it will happen. It is 1/2 into OC into OA plus 1/2 into CF into DF. So this will be 1/2 into 100 into 10, and this will be 1/2 into, this is how much? CF is 15 minus 10 into 5, and DF is equal to minus 50. minus 50, negative velocity downwards. So this is again 500 minus how much? Minus 25, so it is minus 25, 500 minus 125 meters, and that is equal to how much? 375 meters. So basically it is, if we try to portray it in a graphical manner, sorry, in a real, the actual diagrammatic manner, from 0 seconds to 10 seconds, the ball went up 500 meters, okay, then after 5 seconds it dropped back around 125 meters, okay, at 15 seconds. So at this position, at 15 seconds, it is this much portion, which is equal to 375 meters, okay, 375 meters. This is the thing, okay. Then it will move downwards and downwards, like that it will be having the thing, okay. This is the thing. So this is the solution of the